Hey guys, my name's Jason with Mount Baker Mining and Metals, and today I'm in Nouakchott, Mauritania. I've got some MBMM equipment here behind me, and today we're going to be running some tests on their local gold ore to see if the Mount Baker Mining and Metals equipment can recover their gold mercury and chemical free. But first I want to show you where Mauritania is and how I got here, and then introduce you to one of my partners I've been working with to develop a mercury and chemical free gold recovery line. All right, we've just arrived at the yard. Here's our first look at the equipment. Obviously jaw crusher here and the Mount Baker Mining and Metals hammer mill. It feeds down into a cone mill or wet pan mill, and then down onto our 4x8 shaker table. The shaker table tailings run down into these two pits here, and then they have a nice system that takes it down here and recycles the water through a series of baffles here, and they can pump very nice clean water back out from over here on up to the system. So I want to introduce one of the partners, kind of the reason I'm here. This is Daniel Stapper from Pact.
Thanks, Jason. Yeah, my name is Daniel. I'm Canadian, but I work with an NGO, a nonprofit called Pact Inc., based in the US. We do work all over the world, actually, in our mining group. It's called Mines to Market. So there's actually millions of people in this small-scale mining sector around the world, not only in gold, which is my primary focus, but on a lot of other minerals. Here in Mauritania, our project is called the Business Pilot for Responsible ASM Gold. And in this project, the funding comes from the European Partnership for Responsible Minerals, EPRM for short. There was a modern gold rush here starting around 2016, and this project is designed to support the government and the people here in Mauritania to get as much benefit as possible from the artisanal mining sector. In practice, this means support for safer mining and safer mineral processing without mercury. A key aspect of the project is support for private sector partnership, and in this case our local partner is a company called Magma. Magma is a successful geotechnical services company who provide services to the mining sector, and it's thanks to this innovative private sector partnership that the EPRM project has been able to set up this mineral processing facility in the city of Nouakchott, where solutions for the local artisanal mining sector can be tested and optimized.
This morning here we've been working on the jaw crusher, which I think is right over here, and we got it the gap tightened up. It was spitting out about 2-inch rocks like this, and I tightened it up so now it's 1/2 inch minus or 3/4 minus, and that'll heavily reduce the wear on the hammer mill. And the plan is we're going to run it through the jaw crusher. We have about a ton, maybe a little bit more. Run it all through the jaw crusher, all through the hammer mill dry. It's going to be dusty and nasty, but we want to get a nice uniform sample. Once it's through the hammer mill, we're going to mix it up all really good, take a head sample, and then we're going to split it into 6 or 8 different samples that we can run through the wet pan mill and try the shaker table, try some different methods to recover the gold. Here's the ore we're going to be running for our samples. And this is characteristic of the ore they get from their hard rock mines. They mine quartz veins, narrow quartz veins, and the grade here could be running anywhere from 5 to 30 grams per ton. And we're going to try and split these bags up into maybe 6 or 8 different samples and run different samples. I'll explain our methods here in a little minute, but figure out how to recover the most gold from these ore samples without using mercury chemicals, and then we're going to test as a control. Hopefully we can get some of this ore up to the local miners and have them test with their local methods to see which recovery is better. Here's the 6x10 jaw crusher. Got it up on some concrete blocks. Works well. Hasn't hardly been used at all, it doesn't look like. No wear on the jaw dies. So here's what it was looking like before or after the jaw crusher. The big rocks, they had the gap way open, and then we closed the gap, and now it's spitting out nice fine stuff, which will really help the hammer mill with both speed and wear. Because putting these big rocks in, the hammer mill can do it, it just takes a little bit more work, time, and wear on the machine. So it's better if you can get a jaw crusher to reduce the size, and then it goes to the hammer mill much easier and faster. We got our dust masks on. We're crushing dry into these sacks so we can mix it and get a representative sample for our head ore, and then we'll split it into different samples to run and test. We got our first bag there crushed. Jaw crusher's running. We're in production now. Well, this is a test pan from the first 3 bags, and they have that large screen in there, so it's fairly coarse. But I'm going to do a test pan to see if we have any color in this at all, and that'll hopefully tell us if we have some gold to recover here. So there's our little bit of gold. It's quite fine. That one larger piece on the left there, but it's, judging by this test pan, it's fairly low grade. We've got all the ore crushed through the jaw crusher. We're working on getting it crushed through the hammer mill. So we're making progress. Thoroughly mixing our sample up here. We're gonna get a heads assay. And that's what we'll base our results on. By grinding up all the ore, mixing, sampling, and then we'll figure out how much gold's in our ore, and we can determine percent recovery. Here's our 150 kilogram sample. We're going to feed this into the cone mill, run it for 45 minutes. Then we're going to open the gate and let it flow down onto the shaker table. And with this first test, we're going to save the concentrates for direct smelting. Here's our wet pan mill, cone mill. Call them cone mills here. These big huge wheels go around and crush the ore, and when it's crushed they open up this door and it goes out. We're going to run it as a batch system, and so we're going to load the ore in here and let it circulate for half an hour to an hour, and then we'll open the door and it'll flow down onto the shaker table. So we have some water going into the wet pan mill or cone mill. So we'll get the ore spread out as best we can and get the wheels turning. Got our first bag in. We're gonna let it run for a couple minutes and spread that first bag around. Then we'll add the second bag. And here's what it looks like. Going around doing their thing. Okay, second bag. is in. The water level is already halfway up our door. Ideally, I think we want the water level pretty high, but we'll see. We're up and running now. These things turn about 18 RPM. You could probably, if you were running a bigger sample, you would have more water in it. It could take a lot more water if you needed to. Here's the drive mechanism. It's a 15 horsepower motor that runs a big gearbox down there and turns a shaft that the wheels are attached to. It looks like as the wheels wear, there's a pivot point that allows the wheels to stay down on the track. And it just goes around. We're gonna run it for 45 minutes and then open our gate. But here in Chami, the local miners, they'll put 300 kilograms of ore in here, about 2 to 3 inches and smaller, that they hand crush with a hammer, and they'll turn it on for about 6 or 8 hours and put about 2 kilograms, 2 kilograms of mercury in there, and just let it go around for 8 hours and mix it all together. And then they stop it, drain it, collect all the mercury at the bottom of the cone mill that's left after 8 hours, and burn off the mercury, and they recover their gold. We're getting a little leakage down past our gate, which is fine. It runs down this pipe onto the shaker table. But here's the sediment size that we're getting. I would guess it's all at least 100 mesh and smaller, 150 mesh and smaller. That's 150 microns is 100 mesh, and 150 mesh is 100 microns. An easy way to remember it's reversed. But when we turn the shaker table on, this will separate any dense material down into the grooves. There's hardly anything in here. But we're gonna stop it now. It's been 30 minutes since we've been running. We're gonna take a sample and determine the grind size that we have in the bottom of the pan mill here.
Bit of a cemented sediment.
Right on the inside edge?
Nothing on this side, but on this,
oh, I feel it.
Yeah, well, I've got most of it already. It's even bigger.
Yeah.
That's where the coarse sand sort of gets cemented, so that's a problem in the design. And what I've seen at Chami is some kind of a, coming off of the axle, some kind of a little flap to help deal with that issue.
Okay.
So that's something for us to be aware of. Hey, Lamine, you hear what I'm saying? Yeah.
And the outside edge is fine.
It's clear.
Yeah.
But the weird sampling results the first time we did this, where the 30-minute was almost the same as the 15-minute, could be related to that issue. That we hadn't... No, I'll leave it on. Ideally, you'd clean the edge the way I'm doing on that side, Lamine. You really got to push on it to release the cemented material.
Oh, and down here at the bottom, it's coarse. If you work your fingers down to the rail,
yeah,
it's much coarser on the bottom of the rail.
Yeah. Well, the idea being, this what's mixed up. This is going to be our mixing it around, and then getting our 30-minute sample.
Yeah.
Some of it is slightly finer, some of it is coarser.
And your studies in the past have shown that at 30 minutes, it almost was all 100 microns and smaller. Is that right?
Correct.
Yeah.
Yeah. Which is incredible. Even at 30 minutes, that would be that fine.
Yeah.
But perhaps at 30 minutes, I didn't properly get these zones.
Yeah.
I don't remember. I'm maybe more aware of it now than before.
Right. Well, this certainly, I mean, just looking at that, that's not all 100.
No. Ideally, every 15 minutes,
You would clean
do this
out,
test.
yeah, and clean out, brush this back down.
As we're doing now.
Yeah.
You feel there's some really fine there. I'll just leave this sample relatively small.
Yeah.
I'll get it up on the other side. But
Okay. I'll get a shovel and I'll clean out this track around the inside. We've run our 45 minutes. Now we've opened the gate a little bit. Starting to let the fine material that's suspended in the water run down onto the shaker table. It's quite fine. So we'll see how much gold is in this material. Our test pan didn't show very much. And it's working very, very nicely. All the fine quartz is working up to the ramp and then down into the tailings. We have the splitter set almost all the way. So all the quartz is running this way. There's a nice little band of sulfides here. It comes down a little bit going into the number 3. Most of it's coming across into the number 2 concentrates. Very nice and clean. From the last groove here, there's a sweeping band of sulfides that just are grabbed by the number 1. And there's a little line of what might be very fine gold up here under the water bar. I can't focus on it when it's moving, but there's some very fine gold. Maybe you can see it there, working its way down into the number 1. Very nice system. We've got the water mostly drained out of the cone mill. This is the best material. The gold will mostly be down here. And we're gonna work on getting it scooped up and cleaned out. And then I'm gonna manually feed it down here onto the shaker table. We're finishing the run now. We've pretty much got the wet pant mill cleaned out. There's a lot of steel on the table, you can see here. Hopefully there's some gold mixed in with that. I don't see a lot. I think we're concerned we may have some low-grade material here.
These are the samples from the port 4 and port 3, the tails and the middlings.
Okay.
That we'll do grain size on and check for gold.
Get assayed.
Yeah.
And that'll tell us how much we lost.
Oh, and that's a recent one.
There's a little bit of yellow here at the very tips. Very, very fine. Very fine gold. So we'll just have to see. I think when we get our cons, we're gonna pan them out, pan them down a little bit.
Yeah, we should do that.
And then we can get a visual and then we can smelt them, direct smelt them.
Yeah, but we probably have to get the iron out after we pan it, right?
Yes, with the magnet, yeah. Yeah, that's way too much to smelt. We've done our absolute best to get this as clean as possible. Daniel, are you happy?
Yeah, well.
It is what it is?
It is what it is, yeah. Just making sure that the sand that's caked in here is not our material. Maybe some of it is.
Yeah.
Sort of an imperfect situation where we're trying to get it as clean as possible to make sure we're getting the gold values from this test onto the table.
Now I'm going to brush down the table here and move all the concentrates across. It's a soft bristled paintbrush, works pretty well. And this will give us a pretty good showing if there's anything stuck in the grooves. Now here's our little bit of gold here after we brush down the table. And I'll work it down into the number 1 there and we can pan it out and see what we got. This is the number 1. concentrates. Very little in there, which is about how it looks when I run it back home. And the number 2 has a significant amount of sulfides in it, black sand, steel bits on top. So we will combine both of these into one gold pan, and I'm going to pan them down to get a visual check. And we're going to keep out 200 grams. 200 grams, and we'll smelt the panning concentrates and see how much gold we have. I've panned it down. There's probably 50 grams, 100 grams here, something like that. A significant amount of steel. All that shiny whitish stuff is steel. So we're going to use a magnet here and pull out what we can. Yeah, go ahead, Daniel, see what you can get out of there. Here's our gold from our first test. This is through the wet pan mill onto the shaker table and panning down the concentrates. And there is not much gold there. This is from 150 kilograms, and we estimate that's 0.1 grams, maybe less.
Just because it's so fine. The color looks nice on the video, but it's so small.
It's very fine gold. Oh, and there it goes floating away. So we have some head samples off for assay. We'll know more in a day or two about how much the head grade is, but we were hoping for more. We were hoping for what, a couple grams?
We were hoping for 10 or 15 grams per ton.
Right, but a couple grams in the pan is what we were hoping for, right?
Well, yeah, the miners like to say that it averages a gram per sack, and so this is equivalent to 2 good-sized sacks that was processed. So 2 grams. 2 grams would have been wow, but this is way less than 1 gram.
Yeah.